Apianus' Astronomicum Caesareum has been called the most spectacular contribution of the bookmaker's art to 16th century science, and the most luxurious and intrinsically beautiful scientific book that has ever been produced. It also happens to be one of my favourite books. The author, Peter Benowitz, or Petrus Apianus, or the B in Latin, was astronomer and professor of mathematics at Ingolstadt in Germany. He published several works on instruments and astronomy, but his masterpiece was undoubtedly the 1540 Astronomicum Caesareum, and its set of glorious and beautifully constructed Volvelles for computing the true locations of the sun, moon and planets, as well as an extensive set of different eclipse calculations. His work earned him appointment as imperial mathematician at the court of Charles V. The book is famed for its 36 full-page hand-coloured woodcut astronomical figures by Michael Ostendorfer that incorporate a total of 83 Volvelles, 44 silk threads and 12 seed pearls. In his introduction, Apianus claims to have taken 8 years to produce the work and to have coloured, cut and assembled all of the moving pieces himself. From this we can conclude that Apianus had both a very high boredom threshold and a great fondness for eating oysters. Volvelles are movable paper wheels with rotating parts used to assist with complex calculations, or as we like to call them, twisty-turny things. They may be considered to be early examples of analogue computers. Their origins can be traced back to the Arab world of the 10th century astronomer Abu Rayyan Biruni. On the verso of the title are the woodcut coat of arms of the dedicatees, Charles V and his brother, Ferdinand of Spain. These are by Hans Brossemer.
Apianus demonstrates his considerable political skill to go with his prodigious mathematical abilities by using the birthdays of both Charles and Ferdinand as examples throughout the work. The handbook is divided into 2 parts. The first includes 40 chapters with maps reproducing the position and the movements of the celestial bodies, where the second part describes the meteoroscope, an instrument designed to solve problems in spherical trigonometry and relates to the sighting of 5 comets. The Volvelles in the work are each placed within a frame reminiscent of an astrolabe, a contemporary device that modeled the movements of the heavens in 2 dimensions and enabled the calculations of time and space.
The first movable woodcut, which shows the planispheric astrolabe, compresses the stars in both the northern and the southern hemispheres into one plate. According to Apianus' text, the plate depicts 1,033 stars and was based on the first printed star charts published in 1515 by the artist Albrecht Dürer. Following this star chart are 10 illustrations demonstrating the movement and latitude of the superior planets, Saturn, Jupiter and Mars, those furthest from the planet Earth, and 2 inferior planets, Venus and Mercury, which are both closer to the Sun. Unfortunately for Apianus, he went to all this effort just 3 years before Copernicus published De Revolutionibus, and so Apianus was wedded to the Ptolemaic system for describing the night sky, which sees the Earth as the centre of a planetary system, incorporating the known planets as wandering stars, the Sun, the Moon, and all of the other stars making up the final concentric circle at a distance of 20,000 times the Earth's radius.
This results in some fiendishly tortured calculations to describe the changes of position of planets relative to the Earth in the night sky. In order to explain this cyclical variation, Apianus uses a series of mini-orbits, or epicycles, based on a model devised by the 2nd century BC Greek astronomer Apollonius of Perga.
The most spectacular of these Volvelles, which are the work of the artist Michael Ostendorfer, are the dragon plates, which in addition to this one include a title page with a double-page spread of dragon and moon dials. The dragon dial can be used to calculate the nodes of the moon, the 2 points of intersection between the yearly path of the sun and the plane of the lunar orbit. These produce eclipses. Dragons were associated with eclipses, which were believed to occur when the head or tails block the sun or moon. The 13 small dragons indicate different parts of the lunar cycle.
In medieval texts, the nodes are referred to as Ras wal Danav al Tinin in Arabic, Rosh ha-Teli ud-Zenarov in Hebrew, and Caput Draconius, head of the dragon, the latter of which, as any Harry Potter fan will tell you, is also the password to the Gryffindor common room in Harry's first year at Hogwarts.
Apianus is understandably fascinated by eclipses and goes to great lengths to demonstrate their occurrence with some very friendly-faced and charming illustrations. The Astronomicum Caesareum offers 2 examples of eclipse calculations. The first is related to the year of 1500, the birth year of Emperor Charles V, where there was a partial lunar eclipse on the 5th of November. I'm now going to try and attempt to demonstrate this to give you some idea how these wondrous instruments work. This is the lunar eclipse instrument. At the top of the page, there is a panel for setting up the Volvelle, given the anomalies for the moon and the sun. These are obtained from tables given elsewhere in the text. There are then 4 separate panels grouped clockwise around the centre. The first for determining the size of the eclipse, the second for determining the size of the totality, the third one for determining the size of partiality, and finally the last one for determining the angular movement of the moon during the eclipse. To work this through using the example of Charles V's birth year eclipse, Apianus gives us the solar anomaly as 4 signs, 23 degrees and 29 minutes. The lunar anomaly as 9 signs, 22 degrees and 59 minutes. And the moon's latitude is 29 minutes south. The anomaly entry is marked by a small letter C that can be seen in the top panel of figure 2. Moving to the Punta Ecliptica panel, we find the letter C marked corresponding to the moon's latitude of 29 minutes, and the eclipse size can be read off as 10. In the Mora Media panel, the corresponding point shows that there was no totality.
The second part of the book, while nowhere near as pretty, is no less important. In it, Apianus discusses sightings of 5 different comets. Comet fever reached new heights in the 15th and early 16th centuries, when some 21 comets were seen in the night sky. This was, of course, taken to be a sign of the coming of the end of days, and printers did a brisk trade in all manner of pamphlets prophesying Armageddon. Although no one knew it by that name at the time, Apianus saw Halley's comet in 1531, and reported that its tail always stretched away from the sun. He went on to observe this phenomenon in other comets, and was the first to publish drawings showing this. Of course, we now know that the logical extension of this observation is of a helio and non-geocentric planetary system.
The book bears a bookplate. You can see that the coat of arms incorporates a double-headed eagle. This was the main element of the coat of arms of the Russian Empire from 1721 to 1917. The arms are those of Maximilian de Beauharnais, 3rd Duke of Leuchtenberg, and the inclusion of the eagle indicates that the bookplate was printed and the book added to his library after his marriage to Grand Duchess Maria Nikolaevna of Russia, daughter of Tsar Nicholas I and sister to Alexander II. It's safe to say that Maximilian married well.
While Max was a notorious womanizer, it would appear that Maria had no particular beef with his behavior and had an affair of her own with Count Gregory Alexandrovich Stroganov. Court rumors attributed the paternity of her son George to her lover. Maximilian was a keen scientist and a member of the Russian Academy of Science. In 1843, he was appointed head of the Russian Academy of Arts in St. Petersburg, and Maria was an avid art collector in her own right. She took over Maximilian's position as president of the Russian Academy of Arts after his death in 1852. It is not known whether Maximilian or Maria was responsible for the acquisition of this volume, but the combination of groundbreaking science and stunning use of the mapmaker's art made the Astronomicum Caesareum an undoubted treasure of their library.